Hello and welcome to Quantum IAS. We are in day 2 of our daily answer writing series. And in January, we are doing mechanics and waves and optics. So I hope you have written these answers. Let's get started with the question itself. So the first question, find the differential cross-section area of the scattering identical particle. So laboratory differential cross-section area, scattering of identical particle of charge E and mass M if the incident velocity is V. So this is asked from the mechanics section, and just let me tell you one thing. If you map the syllabus here, so in syllabus it is mentioned Rutherford scattering. So it's a good question. I will put it on a tougher side. Okay. So Rutherford scattering is there. Also, if you can see your syllabus, there is center of mass and lab frame of reference. So these two topics, we have combined these topics and given this question to you. Now understand one thing, key factor is Rutherford scattering. When we have studied, हम लोगों ने किस पे फोकस किया था? बेसिकली सेंटर ऑफ मास फ्रेम. So we will get the idea from the Rutherford scattering कि कैसे वहां हमने किया है and apply those concept here. But we have to again change to the laboratory differential cross section area, right? So here two concepts are involved. Now the problem lies here that what should we write in the introduction? So let us talk about the question number 1. What should be the introduction? Whether it should be related to center of mass and lab frame, or it should be related to the scattering, Rutherford scattering. So what I suggest you to write, you should write the definition of differential cross section area, right? So you will define differential cross section area is the ratio of scattered particle per unit solid angle to the number of incoming particles per unit area, right? Now try to understand one thing. Then you can write simply mathematically differential cross section area is equals to d sigma by d phi. D omega, right? D sigma by d omega. You can simply write like that. Also, you can change in the theta mode also. We have talked about the solid angle. You can change into the normal angle also, right? Now, one more thing. Here we need to understand the laboratory differential frame. So this much is more than sufficient for the introduction section. Now understand one thing. इसको यहाँ लिख लेते पहले. So if you talk about lavatory and the center of mass frame, so see, this is basically the scattering of identical charge particle, and this is more or less we will consider elastic in nature, right? So here elastic scattering of two identical particles. Let us establish some relation. So again, let's make some So box is just for the presentation, right? You can choose your way of presenting the things. I'm just giving you the content, how you should write, how the flow should be there, right? But write as presentable as possible. So if you see the center of mass frame, right? So let's say this is mass m charge e, let's say this is mass m charge e. So it will look like that if you see it from the center of mass frame, always lying in the same line. And after the collision, again they will move exactly opposite to each other. You can write the theta dash also, right? And if you look exactly from the lab frame of reference, right? So before collision, let's say this m e v is here. So if you can see there, identical charge of mass, if the incident velocity is v, and we are considering this at rest. So after the collision, what happened? Both particle will move. The first particle with mass m and e, this is the incident particle, will be scattered, and second will be recoiled, right? Such that we know that in the elastic scattering of identical particle, we can simply write that the theta plus alpha is equals to pi by 2. We know that. So you can directly write those things. 15 marks a question, you can write those things, that in elastic scattering of identical particle, we can know that scattering angle plus recoil angle equals to pi by 2. So first thing that we can write. Second thing also we can write that if you convert lab frame to the center of mass frame, so this is the formula that we have studied in the collision, right? So plus cos theta dash, right? Put the value. If you put the value here, these are identical particles, right? So if they are identical particle, it will tend to 1. So sin theta dash 1 plus cos theta dash, so it will become 2 sin theta dash by 2 cos theta dash by 2. We can write sin theta as this, and 1 plus cos theta dash can be written as 2 cos square theta dash by 2. 2 cos square theta dash by 2. We can write like that. So it will become 2 to cancel out, cos theta is constant, it equals to tan theta dash by 2. And from here, we can write simply that theta dash is equals to 2 theta. Dekho, I'm just explaining you these things. You have to write little more formal, right? जैसे मैं बता रहा हूँ, थोड़ा सा और इसको formally लिखोगे. Although this style of writing will also work. So this is the first thing. This is the second thing that we have got, that the theta dash equals to 2 theta. So now, second, one more thing. ये सब तुम्हें लिखना होगा स्टेटमेंट. प्लीज आई एम नॉट राइटिंग बिकॉज आई हैव टू एक्सप्लेन, आई एम डिटेक्टिंग इट. यू शुड राइट कि क्या सोच के तुमने ये लिखा है और क्या सोच के ये लिखा है, राइट? इन विच कंडीशन, इन इलास्टिक कोलिजन, राइट? दिस इज द स्कैटरिंग एंगल, दिस इज द स्कैटरिंग एंगल इन द सेंटर ऑफ मास फ्रेम, दिस इज इन लैब फ्रेम. तो ये सब लिखना होगा तुम्हें. नेक्स्ट वन, whatever the frame is, the particle that is scattered, the number will be same, right? So you will write the number of particle in both the frame will be same. So dn is equals to dn dash. We know that, and we know the formula from scattering, that is I, intensity of the incident particle, sigma theta. Let's convert in theta. 2 pi sin theta d theta is equals to I. It will remain same, right? We know that. ये फॉर्मूला तुमने डायरेक्ट भी पढ़ा होगा. वी हैव आल्सो डिस्कस इन द क्लास, बट आई सजेस्ट यू टू डू इन दिस वे ओनली. जस्ट गो फ्रॉम द बेसिक. ठीक है, एक लाइन का चीज है. सो फ्रॉम हियर यू कैन सिंपली राइट, आई कट जाएगा. यू कैन सिंपली राइट सिग्मा डैश थीटा डैश इज इक्वल्स टू सिग्मा थीटा साइन थीटा डी थीटा साइन थीटा डैश d theta dash. Now put the values here. अगर इसको हम put कर दे, what will we get? This sin theta, right? d theta, and theta dash is 2 theta. ये बन जाएगा sin 2 theta, and what will be d theta dash? It will be 2 into d theta. 2 into d theta. ठीक है. So if you do that, ये इससे कितनी बार में कट जाएगा? तो इट विल बिकम 2 sin थीटा cos थीटा. तो इट विल बिकम 2 cos थीटा बच जाएगा, डी थीटा जब कैंसिल आउट। तो सिंपली वी कैन राइट दैट सिग्मा डैश थीटा डैश इज इक्वल्स टू सिग्मा थीटा बाई 4 cos theta. Why only theta here? Why not alpha here? Because in center of mass frame only the direction changes, magnitude remains same, or and each time the in both the particle will be always in the same line, right? That's why we have written this formula in terms of theta, not in terms of alpha, right? Now just tell me one thing. This we have got the relation, right? Now tell me, if I want to write total differential cross section, few things I have not told you yet, ये बताया नहीं है मैंने, क्योंकि आई वाज रिजर्विंग दैट फॉर दी कंक्लूजन। लिख लेना इस चीज को में। डिफरेंशियल क्रॉस सेक्शन है क्या कि प्रोबेबिलिटी एट ईच डिटेक्टर, इफ यू प्लेस द डिटेक्टर, अगर ये टारगेट पार्टिकल है, इफ यू प्लेस डिटेक्टर हेयर हेयर हेयर, राइट, एट डिफरेंट एंगल्स, व्हाट इज द प्रोबेबिलिटी ऑफ गेटिंग ऑल दोज पार्टिकल्स, राइट? यहां पर देखो दोनों पार्टिकल क्या है, इलेक्ट्रॉन मास me, identical particle है. So which one is the incident particle and which one is the target particle, we cannot differentiate here, right? So डिटेक्टर में कलेक्ट क्या होगा, दोनों ही कलेक्ट होगा, वन ड्यू टू दी स्कैटरिंग एंड सेकेंड वन ड्यू टू दी रिक्वायर. सो you need to write the both cases. So what will be the total differential cross section? So first due to the scattering one and second due to the recoil one. So just write the both sigma theta as sigma alpha, दोनों ही कारण होगा, right? So let us find out this one. Similarly we can find this one also. So for sigma theta, if you remember the Rutherford scattering, right? So if you Rutherford scattering, we have used B is equals to ZE square 4 pi E naught. You can use this formula directly. 15 मार्क्स के क्वेश्चन में तुम डायरेक्टली यूज कर सकते हो. Cot theta dash by 2. Why theta dash? Because we in Rutherford scattering we have considered from the center of mass frame. ठीक है, अभी हमें किससे पूछा गया है, लैब. So now put the values Z1, right? Because same है. So ZE square 4 pi E naught and it is half mv square cot theta dash by 2. See the question, they have given that the incident velocity is v. ठीक है, ये देख लेना, ये हमने सिर्फ थीटा क्यों यूज किया है, आई हैव ऑलरेडी एक्सप्लेन, राइट? बिकॉज इफ यू सी द सेंट्रल मास एंड लैब, दिस इज द ट्रांजिशन. चलो क्या था इसमें, ठीक है. तो पुट दिस, इट विल बिकम, दो से दो खत्म, z tends to 1. So e square, so let us write it as b naught cot theta dash by 2, where b naught is equals to e square, इसका 2 बचेगा, 2 pi m v square epsilon naught, right? So if we know the b, we can simply find the sigma, right? b sin theta. We are more interested in the geometrical terms, so that's why I have placed the model here. So put करो sigma theta dash sin theta dash v theta dash, right? Because we are working from the center of mass frame. ठीक है, we are working from the center of mass frame. So if you put the values, तो यहाँ पे sin theta dash है, यहाँ पे dv by cot theta dash है, put the values, you will get b naught square, just put the values, 4 sin 4 theta dash by 2. Theta dash by 2 is theta. So b naught square 4 sin 4 theta. If you haven't done this, please pause video for 1 minute, right? Differentiate करो, ये आंसर आ जाएगा. ठीक है. Now then what is sigma theta? अच्छा, इसके बीच में you have to place all these things, right? From the center of mass frame of reference, differential cross section can be written as this, that is equals to this. right? By converting into the lab frame, we can write sigma theta is equals to sigma dash theta dash into 4 cos theta. मल्टीप्लाई कर दो इसको 4 cos theta से, तो 4 4 get cancel out. It will simply become b naught square cos theta sin 4 theta, right? Similarly, you can write for sigma alpha also. It will become b naught square cos theta sin. Again, this cos theta we have what from the transition lab to center mass, so it will remain same, but this theta will change because in recoil we are talking about the alpha. So sin 4 alpha, right? And what is alpha? Alpha is 90 minus theta, so sin का क्या हो जाएगा cos, so it is b naught square cos theta cos 4 theta, right? So the total cross section area for this, that is d sigma by d omega, right? We can simply write it as b naught cos theta upon one upon sin 4 theta plus 1 upon cos 4 theta, right? This is the solution that we have got, right? This is a very beautiful question. See, these types of question can be come in the examination, but the chances are not so high, frankly speaking. But this question will help you to explore the concept. Now, but they can ask, बिल्कुल सिलेबस में है, लैब फ्रेम है, डिफरेंशियल क्वेश्चन है, बिल्कुल पूछा जा सकता है. Now, what will be the conclusion? So, conclusion again. First, we will try to explain this. Right? So, बहुत ज़्यादा explanation के पीछे नहीं जाना है. Just write this thing, that is, it is anisotropic in nature. That is, depends on theta. It depends where we will keep the detector. हम डिटेक्टर किस एंगल पर रख रहे हैं, इस पर डिपेंड कर रहा है कितना हमें मिलेगा, राइट? उसके बाद यू विल राइट डिफरेंशियल क्रॉस सेक्शन एरिया विल टॉक अबाउट द प्रोबेबिलिटी, राइट? यू कैन ऑल्सो टॉक अबाउट दैट it is basically the geometrical feature of both particle, right? It doesn't depend upon one particle, right? It is a geometrical feature of both particle, both interaction basically, right? Feature of interaction of the particle. These things you can simply write. Also, अगर और भी ज्यादा मन कर रहा है, प्रोबेबिलिटी की बात कर ली, ज्योमेट्रिकल की बात कर ली, तो हम लोग यूजेस लिख देंगे, एप्लीकेशंस लिख देंगे, राइट? सो वेयर वी कैन राइट द एप्लीकेशन, सो टू फाइंड आउट geometry of material, right? Type of interaction between the incident particle and the target particle, right? So also you can talk about useful in excess scattering, right? Structure, atomic and nuclear structure, बहुत सारा bombarding करते हैं, right? You have also studied in paper 2. So these things you can write in the conclusion. But देखो, इसको अगर मैथमेटिकली बहुत ज्यादा लिखने की कोशिश करोगे कि थीटा पे क्या डिपेंडेंसी है, so in examination I will suggest you that do not go in much detail. बस इतना बता दो that is anisotropic in nature. It is not isotropic. हर एक एंगल में सेम नहीं होगा. It depends upon the theta. It depends where we are placing the detector. फिर जो कॉमन बेसिक बातें जो क्लासेस में हमने की है कि डिफरेंशियल क्रॉस सेक्शन है क्या, राइट? उसका फिजिकल सिग्निफिकेंस क्या है, बेसिकली इट इज द फिजिकल सिग्निफिकेंस and this is the application that we have studied, then you can write these things, right? So this is how you can write. ये बना लेना, right? अगर यही 25 मार्क्स में क्वेश्चन आए तो प्लीज इसको भी ड्राइव कर लेना, that you have studied in the Rutherford scattering also, right? Main particle is that total differential cross section will depend upon both scattering as well as the recoil and the conversion, how you will convert. This is the main essence. So I will put this in a good question. This is a tough question, बहुत लोगों से शायद नहीं हुआ होगा, but still अगर ऐसे क्वेश्चंस आ रहे हैं डेली आंसर राइटिंग प्रोग्राम में, तो try to attempt it. If you are not attempting it, then there is no use of putting these questions. So try करो attempt करने का, even if you are not writing answer of 1, you should have written the answer of 2. देखो, determine the location of the center of mass of uniform solid sphere of mass m from the center of its base. ये 2 से 3 बार आ चुका है एग्जाम में, 2 तो पक्का मुझे याद है ईयर भी, right? So in UPSC they have asked this same question, uniform solid sphere, right? And it is a typical question of 11th class. 11th class का कोई बच्चा होगा, उसके स्कूल एग्जामिनेशन में यही सेम क्वेश्चन आता है, right? So let us try to write. This was an easy question. So question number 2, if you write the introduction, what you will write in the center of mass? So center of mass definition, simply. Right? So I'm dictating it. If you want to write, you can write. And I hope सबको पता है, you can write your own definition, I will suggest. But if you want to write, I'm just dictating it. So center of mass of a system of particle, right? Whether it is continuous or discrete. So center of mass is the imaginary point in the space. Why I'm writing the space? Because it can be on the body, within the body, outside the body, anywhere in the space it can be. It is the imaginary point in the space for which the total inertia, bracket में लिख दो, mass of the body can be treated as concentrated or is concentrated. जैसे लिखना हो, right? Try to understand one thing. 2 things I have written, right? In the space for which the total inertia of the body, इसको body काट के लिख दो, system ज्यादा सही रहेगा, discrete or continuous, right? So center of mass is the imaginary point in the space for which the total inertia mass of the system can be assumed to be concentrated. यहाँ पर कर दो, can be assumed to be concentrated, right? एक definition बना लो, उसको याद कर लेना. So let me give you 2 key points. Space, because it can be anywhere in the space. Try to understand these things. Inertia, why I have written inertia and bracket में mass? Mass इसलिए क्योंकि सब जनता जानती है mass, it is on your tip. But try to write inertia. Why inertia? Because if you write the inertia, you will get a feel that all the translatory motion of the system of the particle or the system or the body can be treated just by assuming that point, center of mass को लेके कर सकते हैं, right? So we know that translatory motion मतलब पूरे body का जो translatory motion है और center of mass का motion है, that can be considered as same. That's why I have written this. And again, it can be system, it can be discrete, it can be continuous, right? उसके बाद you will write मैथमेटिकली. अब हमेशा देख लिया करो कि सिस्टम कौन सा है, कॉन्टिन्यूअस है या फिर क्या है, राइट? सो मैथमेटिकली आर सेंटर ऑफ मास इज इंटीग्रेशन आर डीएम. नाउ अंडरस्टैंड वेयर, ये बहुत इंपॉर्टेंट है क्योंकि वी आर कंसर्न विद द कॉन्टिन्यूअस सिस्टम, तो ये फॉर्मूला तुम्हें कॉन्टिन्यूअस सिस्टम के लिए लिखना होगा, ठीक है? वेयर आर इज व्हाट एंड वर्ड डीएम इज व्हाट? आर सेंटर ऑफ मास, तो ठीक है, सेंटर ऑफ मास ऑफ द सिस्टम. R is the center of mass of the DM, that is the elementary particle, and DM is the elementary particle taken into the consideration, elemental mass that we are taking into the consideration, right? And R is the center of mass of the that elemental mass. So this should be your इंट्रोडक्शन. यहां तक इंट्रोडक्शन हो गया. 10 मार्क्स का क्वेश्चन है. एक फिगर बनाएंगे हम लोग, राइट? तो यहां पे दिया हुआ हेमिस्फेयर के लिए, so we will draw the hemisphere and then we will do it. So I'm drawing freehand. ठीक है, let's consider it as y axis, this as x axis, right? Now how will we do it? देखो ये जो है ये बेसिकली सॉलिड हेमिस्फीयर है. ये हमेशा लिख दिया करना कि क्या है, and try to put in box if possible. Now let us consider, दिया है फिर कंसिडर करना होगा. Yes, mass m is given, radius r is given. ठीक है, on from the base is given already. So there is two way of writing the x and y, right? I will suggest you to find out x center mass as well as y center of mass. ठीक है, so let us take the element. So क्या करेंगे हम लोग, r पर जाकर एक dr का हेमिस्फीयर लेते हैं, राइट? याद ही होगा सबको, फटाफट कर लेते हैं काम. सो r पे जाकर हमने हेमिस्फीयर का dr लिया, राइट? सो व्हाट विल बी dm? सो dm इज इक्वल टू रो इनटू dv. ऊपर देखो यूनिफॉर्म लिखा है, यूनिफॉर्म सॉलिड हेमिस्फीयर, राइट? सो ये लिख लेना. Again, these small things we have to write, right? Where rho is the density of that, and rho is equals to m upon 4 pi 3 r cube, 4 pi by 3 r cube, right? 2 pi, sorry, hemisphere है ना. m is equals to 2 pi by 3 r cube, right? So if you put dm, put कर दो तो ये ऊपर चला जाएगा 3m 2 pi r cube. What is dv? What will be the elemental volume? ठीक है, we know that surface area into dr, so 2 pi r square, छोटा वाला r square into छोटा dr, right? So if you consider 2 pi से 2 pi खत्म, it will simply become 3m by r cube. These are constant, r square dr. This is the dm that we have got, right? Now let us find out x center of mass. So x center of mass क्या होगा, integration x into dm upon dm, right? Put this value, you will get 0. Put कर लो 0, y तो हम लोग निकालेंगे. But I will suggest you that put this value, write 0, and then you will write that center of mass, या फिर लास्ट में लिख लेंगे, पहले x और y निकाल लेते हैं फिर दोनों के बारे में बात कर लेंगे. y center of mass, so y center of mass is y dm by dm. देखो ये जो कैलकुलेशन है, these are just 11th क्लास. ये स्टार्टिंग में ये कैसे इंट्रोडक्शन लिखना है, कैसे मैथमेटिकली फॉर्म करना है, और कंक्लूजन क्या लिखेंगे, दैट इज जस्ट आवर वर्क. बाकी क्वेश्चन बहुत आसान है. सो व्हाट इज बी डीएम? ये सिंपली एम आ जाएगा, टोटल मास ऑफ द पार्टिकल, तो इसको बाहर निकालो. तो 1 by m इंटीग्रेशन y, अब बताओ y कितना आएगा. दिस इज द हेमिस्फीयर, एंड व्हाट इज द सेंटर ऑफ मास ऑफ हेमिस्फीयर? r/2. याद करो, center of mass of hollow hemisphere is r/2. You can simply write this. And I hope, और मैंने क्लास में बहुत बार बोला है कि स्टैंडर्ड जितने भी फॉर्मूले हैं प्लीज डू रिमेंबर, क्योंकि 10 मार्क्स के क्वेश्चन में तुम फिर हेमिस्फेरिकल सेल का निकालने नहीं बैठोगे, राइट? जस्ट पुट द वैल्यू. सो y की वैल्यू हो जाएगी r/2. एंड व्हाट वाज dm? dm वाज 3m r cube r square dr, from where 0 to r. So if you put these things, मुझे याद है फॉर्मूला, that's why I'm writing 3r/8. 3r/8, राइट? नाउ यहां तक जो है ये कैलकुलेशन जो हमने किया है इस पेज पे, दिस इज जस्ट फॉर 11th क्लास। इसके बाद जो कंक्लूजन लिखेंगे, इंटरप्रिटेशन, दैट इज वेरी इंपॉर्टेंट, राइट? सो यू कैन सिंपली राइट द सेंटर ऑफ मास ऑफ द सॉलिड हेमिस्फेयर इज 0,3r/8, right? What represent? So what you will write in the conclusion? Conclusion में हम अगेन दो चीजें लिखेंगे, एक मैंने बताया था इसको एक्सप्लेन करना, और दूसरा वैल्यू एडिशन बताया था ना, कंपलसरी एंड वैल्यू एडिशन। सो कंपलसरी में इसको एक्सप्लेन करेंगे। So x center of mass is 0, that basically define that center of mass lie on the plane of symmetry, right? Center of mass is symmetrical point, whether it can be plane of symmetry, line of symmetry, point of symmetry, it is always a symmetrical point, and x बराबर 0, ये देखो symmetrical है, इधर जैसा है वैसे ही इधर है, right? So x बराबर 0 जो हमने कैलकुलेट किया है, it basically verify that center of mass lie on the symmetry. 3r/8, what does this represent? You can simply see that 3r/8 is less than r/2. That means if this is the hemisphere and this is the r/2, center of mass कुछ नीचे है उसके. That means one more property of center of mass that we have studied, that center of mass tends to lie near the heavier mass, near the heavier mass, और दी हेवियर पोर्शन ऑफ द बॉडी। हेवियर पोर्शन मतलब जिधर भारी है उस साइड टिल्ट करता है, उस साइड टेंड करता है वो पॉइंट, राइट? सो दिस इज द कंक्लूजन, यू हैव टू राइट दिस इज द इन्फ्रेंस और द इंटरप्रिटेशन ऑफ द रिजल्ट दैट यू हैव गॉट। यहीं पर छोड़ दोगे देन यू विल नॉट गेट द फुल मार्क्स, मतलब जो भी एंटिसिपेट कर सकते हैं, राइट? नेक्स्ट, व्हाट एल्स वी कैन राइट? लेट्स सी इफ यू हैव टेकन a sedan, sorry, a SUV and a sedan, right? Let's say ये वर्ना है, ये स्कॉर्पियो है। You know that it will travel much faster than this, मतलब ये गाड़ी जो है वो चिपक के चलती है रोड से, right? Much stability in Verna than in the SUV. If you have taken the ride, you can simply understand. Or the sports car, if you have seen, it is had उस तरीके से डिजाइन होता है such that center of mass lie in the bottom such that it can be stable, right? So basically ये जो है ऑटोमोबाइल सेक्टर में इसका एप्लीकेशन है, राइट? अब देखो सेंटर ऑफ मास का एप्लीकेशन मैंने क्लास में बहुत सारा बताया है, बट इससे हमने क्या निकाला है? एक तो सिमेट्रिकल हो, राइट? तो सेडान इज बेसिकली मोर और लेस, स्पोर्ट्स कार मोर और लेस सिमेट्रिकल, ठीक है? बट उसका जो बेसिकली जो स्ट्रक्चर होता है, राइट, दे आर कॉम्प्रेस्ड सच दैट कि सेंटर ऑफ मास कहां लाई करे? जमीन से, जो हमारा रोड है उससे और नजदीक हो, उससे और ऊपर ना जाए, राइट? तो दिस इज बेसिकली व्हाट वी यूज इन द ऑटोमोबाइल सेक्टर। तो यू कैन बेसिकली राइट दिस थिंग दैट कि in automobile sector or in automobile designing, right, the engineers try to design such a way that the center of mass is lowered and it is nearer to the ground so that it maintain the speed, right? Also for maintaining a good speed, also stability in sharp turns, right? So all those things you can write, right? अब देखो यहाँ पर जैसे मैंने क्लासेस में बताया था एक बैरी सेंटर का कॉन्सेप्ट याद है, सन एंड मून वाले पे। तो अगर जब वो दो पार्टिकल का बात आए, राइट, जो रिवॉल्व कर रहे हैं या टू पार्टिकल, तो टू पार्टिकल के लिए तुम बैरी सेंटर का एग्जांपल लिख सकते हो एप्लीकेशन में, बट डू नॉट राइट दीज थिंग्स हियर। व्हाई आई एम टेलिंग यू दैट? बिकॉज व्हेन आई हैव स्टार्टेड टीचिंग एंड टेलिंग गाइस की एप्लीकेशंस लिखना स्टार्ट कर दो कंक्लूजन में इंटरप्रिटेशन के बाद, वो कुछ भी एप्लीकेशन लिख देते हैं, बट ट्राई टू राइट जो उससे रिलेटेड हो, दैट विल फेच मोर मार्क्स, राइट? Okay, so that's all for the day. We will meet in day 3. I hope you are writing, right? Please maintain the streak. Thank you. Good night. Bye bye.